Marine Life Center in Juno Beach, Florida. But thanks to the ingenuity of veterinarians, biotech experts, and even an orthodontist, Andre received high-tech treatments that are usually reserved for humans. Melissa Ranley is the coordinator of the Marine Life Center's Turtle Hospital.
Because of his injury and the infectious fluid in the body cavity that needed to be removed, as well as the collapsed lung, we knew that we needed to try something different, and that was the perfect technology for this. And that wound care, negative pressure wound care system has been used in humans very successfully, as well as some other animals. So this was the first time that we know of it being used on a sea turtle in the water, and especially a large turtle like Andre. So we had to find some ways to creatively get that to work so we could put an active turtle in the water and that bandage not leak.
But Andre's troubles were just beginning. The huge gashes on his shell had exposed internal organs. That's where orthodontist Alberto Vargas stepped in. Dr. Vargas placed custom-made braces on each side of the wound to push and pull on Andre's shell, just as they do on human jaws to stimulate growth.
Whenever you stretch certain parts of bone, the growth centers, kind of like the sutures in a baby's skull, when you stretch those, bone starts to grow and fill in. So just like a baby's skull starts to get larger and the head gets bigger because of the brain growing, same thing when we're applying pressures to the turtle. We're applying pressures to those sutural areas and we're causing bone growth.
As a result, Andre grew 2 centimeters of new shell in some areas. In another innovative medical technique, Dr. Vargas said he used custom-made palate expanders on Andre's shell to help seal it back together.
For the profession, it makes me think that we have to stop using just traditional science and we have to start thinking outside of the box. We have to start exploring and stop depending on what happened last year, 2 years ago, 3 years ago, and we have to make what's going to happen 2 years, 3 years from now. So this really taught me to think way, way outside of the box.
State-of-the-art medical procedures helped put him back together again. These included so-called VAC therapy, featuring patches that create small vacuums around wounds to help them heal faster. The patch provider Kinetic Concepts also equipped Andre's doctors with small skin grafts known as Stratus Reconstructive Tissue Matrix implants to help put Andre on the mend. After 13 months of treatment, Andre's moment arrived. His shell was hard enough to survive the depths of the Atlantic, and experts at the center were optimistic about his future. Some 500 people showed up to cheer as Andre made his triumphant return to the Atlantic Ocean from the care of the Loggerhead Marine Life Center in Juno Beach, Florida. It took 6 volunteers to hoist him off a trailer before plunking him down at the water's edge.
Our hope is that he might even get out there and mate this season and create more little Andres for the next generation.
But Andre was in no rush, making his way home slow and steady. Scientists have been mystified for years about how the woolly mammoth survived the extreme temperatures of Siberia during the Ice Age. But now, a team of 15 international researchers has come up with the answer. At the Australian Centre for Ancient DNA in Adelaide, the researchers took DNA from the bones of a woolly mammoth found in Siberia and grew blood.
30,000 years and stuck a needle in a mammoth and took some blood out of it. Started doing some really weird things. That was when it started getting quite exciting because we realised that it was completely unique. The structure of this thing, no one had ever seen it before. It was different to any other mammal we'd ever seen.
The researchers have concluded that the mammoth's blood structure was the key to its survival. They believe the animal's blood remained liquid enough to deliver oxygen to the extremities.
What it showed us is that they were incredibly cold tolerant. They could let their extremities, the tail, the ears, the feet, cool right down, and their blood would still keep on working, the oxygen would still get to the tissues, and that means they would save a whole bunch of energy.
This new method will now be used to study other extinct species like the Tasmanian tiger. Well, that's it for this episode of Animal Tracks. Bye for now.